Hello, my name is Connor Gardner, and this is a brief video walkthrough of a program that I created to explore the OSI model, specifically on the software level. And so in order to do that, I just wanted to go through providing a brief rundown of what my program does, its purpose, and some of the applications of what I intended its purpose to later become. So with that being said, this is a client-server-based application. Essentially, my thought process was that I could use a RESTful API provided by Yahoo Finance, or in this case entitled Y Finance, that connects to an online stock price server. It pulls data from this server, combines it to my server via request, and then with a client in which I've made a dashboard for, this client is able to retrieve that information as requested from the server, Y Finance, and display it, so that we can explore kind of the 7 different layers of the OSI model, the different frameworks that go into this, and again, how behaviorally this would work on a software level. So with it being said, in order to run this server, or to even start the server, I've included that here within my README file. You would need to open a terminal, run python server.py. Subsequently, after that has been established, and I've created some runtime indicators to showcase that it is indeed running, you will then run a separate script. This is for the client. You will need to open a separate terminal window and execute this using what I have used library-wise Streamlit, which is basically just a web GUI AppKit interface that allows you to freely and locally host web pages. It eliminates some of the potential burden of having to hard code a framework. And so for that purpose, it's super awesome. But once that has been initiated within Streamlit, in which once both the server and the client are running congruently together, this will launch. And again, I'll walk through this with you in just a few moments. But the purpose of this, and a way to kind of validate that the data itself has been retrieved from the server, I decided to just use a CSV file in which, once the server has accessed stock information, for example, if we were to access Apple stock, it would populate the request and store it within a CSV file. And I've done this kind of with 2 different intentions. First, to validate that data was actually retrieved and then nothing was lost. And in order to do that, I actually used the TCP protocol instead of UDP, which again makes it so that none of our packets theoretically should be lost during this transfer process. But outside of this, again, if enough aggregated data was pulled from the stock market by the user itself, they could use a couple of different dependency libraries to explore data. And in this case today, it's quite limited because I haven't pulled a whole ton of stock data. But for the purpose of providing a walkthrough and a visual for this, I have used a visual library here within Visual Code Studio to help kind of showcase how this works. With that being said, network communication wise, I have included within this README how the OSI model itself interacts, and on the 7 different layers, how this works fundamentally within my program as well. I've also included some of the different libraries that were used within my dev environment, and also some that I hope to use in the future as this program continues to develop, as well as useful documentation and ideas that I have about how to use this. So with that being said, let's run this program and let's showcase how it works in real time. So opening up a terminal, we'll run python server.py. I just want to showcase what our script looks like. This is, again, my server script. I've used a couple of different libraries. One of the most important that makes this whole communication process via TCP possible is our import socket. This is a Python-based library that allows us to form connections and essentially be able to transfer data between 2 different devices. In this case, it's a server and a client relationship, again, as previously stated, but I'll go over my program briefly just to showcase how it works. Initially, I wanted to create a function that would be able to transpose stock price data, specifically with what is known within the industry as ticker symbols. These are used for all publicly traded stock exchanges and companies that are available for public trading. So with that being said, I was able to create a way to transpose that data within this function. In addition to that, I wanted to save the data and save it to a CSV file in that I could track three different components, specifically the timestamp, so that visually over time you could see when data was extracted from Y Finance. In addition, the ticker symbol, or again, the stock symbol itself, and then the price at which it was traded. This, of course, is again saved to a CSV file and then saved locally within a repository under the name stockprice.csv. Now, this is the magic behind this server-based application, though, is actually the socket library, again, allocated specifically to Python. And there are several different methods within the socket library that allow us to initiate, open, and then close communication, specifically in sending packets. So some of those that were mission critical to this were a bind, which allows us to identify where our server host is, as well as the port, which was previously mentioned, as well as then opening up a listening state, which, as we saw within the server itself, is still transposing. But with that being said, how is the data itself received? Well, we have to accept it, and this is done via the connection and the address. Again, the local IP address, because this is being run on a local machine. And with that being said, once the data is received, though, it has to be decoded and then later encoded. But the data itself is, of course, again saved to a CSV file with the three different columns that I've previously indicated: our timestamp, our ticker, and our price. This is for the client side of this, again, client server-based relationship, was that it would be super helpful if I had a web GUI or a graphical user interface in which a user could freely access this data and have it displayed in a manner that is pleasing to the eye. So with that being said, I decided to use the Streamlit library. The Streamlit library is super nice in the extent of being able to host a locally web-based application with some different customizable options to make it so that, again, this data can be freely transposed and accessible. So with that being said, again, we're still using the same vital details for our IP address and our port. With that being said, though, we move into some of our Streamlit application. In syntax web page, we have our title, subheader, and some just detailed information about what the purpose of this Streamlit application is. Well, part of my thought process was, how useful would it be to have, say, 20 of the top publicly traded tech stocks? And so I just used a static list and a drop-down menu, as seen here, that allows you to request data, again, from one of these ticker symbols. Again, there's 20 or so of them included here. Goes through the same process of requesting and receiving that data. Again, it has to be encoded and decoded. And again, this is all handled by the server itself, as well as I also included a way for this data to, again, be saved to a CSV file. But more specifically, so that once that CSV file, again entitled under the name stockprice.csv, is created or generated, it can be hosted within our Streamlit app, and that data can be analyzed within the Streamlit app itself to see, for example, trends or guidelines that are accessible within that. But it has, of course, been acquired from our server. It will, of course, be saved in our stockprice.csv. And again, there are three columns to showcase this. We have our timestamp, our ticker, and our price. And if, for example, you wanted to visualize this data, to view this data, though, there are a lot of different options out there by way of dependency libraries that can allow you to visualize this data. This, for example, is just a preview of how this can be done. Within this, though, it allows us to see prices of different stocks at the time that they were accessed, as well as the different prices in which they were traded for that day. And if this was aggregated over a large span of time, you'd be able to see different trends in stocks that you're watching, for example, and the price at which they were traded, which, again, this is a great use of being able to visualize and see your data in real time. Once the Streamlit application itself loads, it will again load from a local host The contents of those details have been excluded from this video for the purpose of just showing my applet, which again was created in Streamlit. So just to give you a brief rundown of how this would work, again, my thought process was we're going to use the Y Finance RESTless API. Again, this is connected via TCP socket. And part of the development that went into this program specifically is I wanted to see tech stocks, specifically within the sector, some of the highest performers and how they actually perform in real time. So I created a drop-down menu, which is seen and displayed here. For example, if we wanted to see AMD and the stock price data that was initially closed, again for AMD before the weekend closed, we would click the Get Stock Price. It would execute a runtime request. The server sent this request, and our symbol, again, extracted using the ticker AMD, showcases this last price at which it was traded. Now, the nice part about this, again, I've included another drop-down so that we can see the historical data that has been requested specifically from this local machine. And if we were to do that for AMD, we would see that 2 requests have been made. Request has been made. For example, in this case, we requested Google stock. This is what is actually happening on the server side. We have that by our local IP address, which we are connected to, and our port, and our host port, we have accessed Google data. Which still some things that I would like to add over time to improve the continuity of the data itself, as well as how it's visualized, and of course, how this Streamlit application, or this GUI in this case, can be accessed for users. For example, it'd be super helpful if I could schedule events that could be automated. For example, in finding my top 20 occurrence event in which a request is pulled, so that, for example, at 4 different points during the day, that data can be accessed and utilized, or even by hourly. In addition to that, it would be super nice to have the ability to search for stocks individually, which again could be implemented here instead of just having a drop-down menu to search for any sort of stock that you would want. That would open up a wide umbrella of potential users that would want to be able to see data like this from the stock market in a free-to-use manner. Outside of this, I just want to thank you for being a part of this video walkthrough and hope to see you again. Thank you.